In this video, we will be looking at interpreting quadratics. By the end of this lesson, you should be able to determine the domain, range, zeros, intercepts, roots, solutions, and behavior of a quadratic function. I will be able to evaluate quadratic functions. So let's take a look at what that means. In situation number 1, Chris threw a rock into the air from the ground. The following graph, right here, shows how high the rock was in the air over an interval of time in seconds. The graph can be modeled by the quadratic function r of x equals negative x squared plus 8x, where r represents the height of the rock in feet and x represents the time in seconds. How high was the rock after 1 second, after 4 seconds, after 10 seconds? So we're going to use this graph to answer these questions. So the questions ask how high was the rock after 1 second. They want to know how high it was after 4 and after 10 seconds. Let's take a look at our graph first before we try and answer any questions. So this shows Chris threw a rock. He started at the ground, so here he was 0 feet. He threw the rock up in the air, and as time passed, the rock went further into the air. It reached this point, and then it started to come down. Gravity took over, and it came down, and it reached the ground again. So after 1 second, we want to look at our graph and find seconds. So here's 1 second. I'm going to go up. And here's where my curve hits 1 second. And I look over here on my y-axis and I have 6 feet. Let's take a look at the next one. After 4 seconds, I want to find 4 seconds and go up here, up. Looks like the height of the graph. We're up here. Now our labeled numbers stop there. If you notice the pattern, 2, 4, 6, 8, 10, 12, 14, 16. So at 4 seconds, the rock was at 16 feet high. My last one says after 10 seconds. Okay, so look at my seconds, and they stop at 8 here. So at 8 seconds, the rock returned to the ground. Now with feet, we were able to extend that. If we extend this to 9, the rock stopped here. The rock hit the ground, and so we're not counting to 9. 10 seconds, we call, is not in the domain. We cannot go over our x values. Remember, we have x and y. Our x values cannot go there because the rock hit the ground. It doesn't make sense in my problem, the domain. And we're going to talk about that more during this lesson. So let's continue with some definitions. We have a quadratic equation. And that's an equation that can be written in the standard form. So we have a standard form, ax squared plus bx plus c equals 0. So it's an equation because it's equal to 0. So there's my quadratic equation. A quadratic function is a nonlinear, so it's not a line, that can be written in the standard form y equals ax squared plus bx plus c, and whose graph is a parabola or a U-shaped curve. A parabola is going to look something like this. That's my parabola shape. Vertex is the maximum or minimum point of a parabola, also known as the turning point. So on my parabola, my vertex is the turning point. I can also have parabolas that face down, and my vertex would be that turning point. So let's take a look at a little bit more of that vertex. So we look at the behavior of quadratics. For these examples, we're going to label where the function is increasing and decreasing, the ordered pair for the vertex, and whether the vertex is a maximum or minimum. So if we remember back to our very first unit, we talked about increasing and decreasing. So here, my graph comes down, and that is decreasing. And that is decreasing. my graph is decreasing. Then my graph comes up, and now it is increasing. Okay, so I'm decreasing and I'm increasing. And this point right here, if you remember, that is my minimum. It is a minimum. And that point is my vertex. I'm going to label that point. That is the point 2, -1. So that is our increasing, decreasing, our vertex, and our maximum and minimum. Let's flip our page over and take a look at the domain and range. I mentioned domain when we talked about our first situation here, that 10 seconds was not in the domain, it was beyond my quadratic. So here, we're going to write the domain and range of each quadratic function. So if I look at this graph has arrows on the end. It's going on forever in these directions. So here, it's going on forever and ever. There is no stopping point. Like in my example, it stopped. It had a starting point and a stopping point. There is no starting and stopping point here, so my domain is all real numbers. Okay. My range, if we remember, is my domain was my x values. Looking at the x-axis. My range is going to be my y values. So I'm looking at this graph and trying to see the y values. Well, if I notice here, remember range is up and down. There's my y-axis up and down. And this graph goes up. It starts here and it goes up. It goes up forever. So the lowest point of my graph is right here when y equals -1. So my range, I'm going to write it with these curly brackets, y, and then a line. And I'm going to say y is greater than or equal to -1. So all of my y's that are bigger than -1 will work for this graph. It won't work down here. And finally, let's take a look at our next example talking about intercepts, zeros, roots, and solutions of quadratics. If we remember, intercepts, zeros, roots, and solutions all mean the same thing. So let's label those parts on our graph here. So I'm going to write the y-intercept, the x-intercept, the zeros, roots, and solutions for each quadratic. So if I look at this graph here, my y-intercept, so here's my y-axis, where my graph touches my y-axis is right there. So my y-intercept is a point 0, 2. My x-intercept is where my graph touches my x-axis. And I have 2 spots there. So my x-intercept is going to be the point 1, 0 and the point 3, 0. I have 2 x-intercepts. Zeros mean the same as x-intercepts. So I can write them right there. My roots, I can write this just a little bit differently. I can say x equals 1 and x equals 3. Those are my roots. Still looking at 1 and 3. And lastly, the solution set, I can also write them using those curly brackets. And I can write 1, 3. 1 and 3 are my solutions. We're going to come back and finish the rest of these examples in class, so please make sure you bring your notes to class with you and we'll continue to practice.